Okay, this is problem 2. Of course, your background would be the same. If you need a repeat of this, then go back and watch the previous video from 531. Okay, this is the function here. The first thing, of course, is the domain. That's where you kind of start. That's where the problems are. You take the denominator, set it equal to 0, and solve. So negative 16 makes it 0. When the denominator is 0, it's undefined. If the numerator is 0, those are your zeros, or your x-intercepts. So now we write the equation of the vertical asymptote. So that is x equals negative 16. What is the equation of the horizontal or the oblique? Well, the highest power is on the top. So since the highest power is on the top, we won't have the horizontal, we'll have the oblique. And when we have the oblique, you can use synthetic division to divide the bottom into the top, and then the result will give you the equation of the oblique asymptote. So we're going to use synthetic division to divide the bottom into the top. Okay, here is your synthetic division. Since you were dividing by x plus 16, you change the sign, and then you use the coefficients of the numerator, which was 1, negative 8, negative 9. You bring down the 1 and you say 1 times negative 16. That's negative 16. Put it right here. Add negative 8 plus negative 16 is negative 24. Then you multiply again. A negative times a negative is a positive, and you get 384. 9, negative 9, positive 384, you're basically subtracting, gives you 375, but you don't have to worry at all about the remainder when you're looking for the oblique asymptote. Just this part's going to give me the oblique asymptote. Since I started with my highest power as x squared, this stands for 1x minus 24, and that is the oblique asymptote. Then it says to choose the correct graph below, and it ends up being B, but you do want to double check everything. This one was a little bit stronger, I think, in trying to figure it out. So you would factor this, factors of x squared, x and x, factors of 9 that have a difference of 8, 9 and 1, the 9 being negative, the 1 positive. When you solve those, you'll get negative 1 and positive 9. Those are your x-intercepts. Your y-intercept, sub in 0 for the entire function, not just the top and the bottom, and you get negative 9 over 16. That is your y-intercept. This is the best graph right here. And to verify it with Desmos, I put it here. This negative 0.563 is like your 9 over 16. You had an intercept of 9, intercept of negative 1. Don't really, that may be like the low point right there is all that is, and you really didn't have to come up with that, but that's kind of what that is. That's just the low point of the graph in that area, like a local minimum. All right.